Back. So in this video, we will discuss the electrical permittivity, or we can say permittivity of the medium. Okay. Also, in the last video, when we will discuss the Coulomb's law, there we have discussed what permittivity is. Here was just we will see the electrical permittivity, or you can say the permittivity of the medium, and it is denoted by epsilon. Okay, the symbol to represent electrical permittivity or permittivity of any medium. Okay, it's epsilon. So what it is a constant which is defined for all the mediums to know how far the medium permits the electrical interaction between two charged bodies. This we have already seen if you're having two charged bodies Q1 and Q2. Okay, so the medium, okay, any medium which will be there between these two charged bodies, it will give us how the electrical interaction will be there between these two charged bodies. We've already studied that force is inversely proportional to the permittivity, right? That means if the permittivity, okay, between these two charged bodies for any medium is more, then the force will be what? Less, right? Because the medium will have more force within it. So the force on the other, okay, charge body will be less. Means when permittivity, okay, permittivity is more, then the force is less. This is the inversely proportionality. Here the symbol is given, and this electrical permittivity, it is also called as what? It is also called as absolute permittivity. It is also called as absolute permittivity. Okay, so this is actually a very important topic that you need to know without any confusion. You need to remember that if you're writing only epsilon, that is the permittivity of the medium. Sometimes we use the notation epsilon m also to denote the permittivity of the medium. Both are correct. Okay, so keep these concepts very clear, because in second chapter and to solve many problems this will be required. Clear? We will see the dimension of electrical permittivity once after discussing the relative permittivity. So now let's see the relative permittivity, which is denoted by epsilon r, and the dielectric constant is denoted by k. So what is relative permittivity? It is the ratio of the permittivity of the medium to the permittivity of the free space. And epsilon r, it is denoted by, or you can write dielectric constant. Both are having the same formula. Okay, so it is the ratio of permittivity of the medium. So I'm writing it epsilon to the free space. Okay, so you need to remember epsilon r is relative permittivity. Relative permittivity because it is the relation, okay, of what? Medium to that of free space. And epsilon is what? It is the permittivity of any medium, okay, or all medium. And epsilon naught, it is the permittivity of free space. This is the permittivity of free space. And k, it is the dielectric constant. So from here, if you see, you can write the permittivity of medium to be equals to k epsilon naught, right? And you can substitute this in the formulas. Okay, we know the force, okay, for vacuum, okay, for vacuum, or you can say free space. The formula of force is what? 1 by 4 pi epsilon naught q1 q2 by r square, right? And for medium, what you are having? For medium, you are having fm, okay, I'm writing it as 1 by 4 pi epsilon m. I'm writing here. As I said, this can be denoted as epsilon m also. Okay, this is q1 q2 by r square. Now if you take this to be equation 1 and this to be what? Equation 2. So equation 1 by 2 will give you what? F naught by fm. Obviously this terms will get cancelled, and here you will have what? In the numerator, f4 pi epsilon m or epsilon, both are same thing. This is 4 pi epsilon naught, right? This will get cancelled, and you will have finally f naught by fm, that is equals to epsilon m by epsilon naught, which can be further written as, how you can write this to be further when you will write this particular thing. Okay, just see, it's quite very easy. F naught by fm, epsilon m, medium by, this is the ratio of medium to free space, which is denoted by k. And you can write here for medium, Fm is equals to what? 1 by K F naught. Means for any medium, okay, the force will be what? 1 by K times of the free space. This is a very important thing. Means it will reduce by, for any medium, the force will reduce by how much? 1 by K times of the free space. Clear? This is what you need to remember. Now you see, in order to calculate the dimension, okay, now let's see the dimension part. Okay, you are having the force is equals to what? 1 by 4 pi epsilon naught q1 q2 by r square. Okay, so for any medium, when you will write, F will be equals to what? 1 by 4 pi epsilon q1 q2 by r square. And you have already seen epsilon r, or you can write K. It is equals to medium divided by naught, right? Epsilon naught. Permittivity of medium divided by free space. So from here, what you will get for medium, the permittivity of medium is K epsilon naught. Just you need to substitute this value here, and you can write F is equals to what? 1 by 4 pi K epsilon naught. And here you are having Q1, Q2 by R square. Clear? And if you are not doing this, then also it's okay. The reason is that because these all are constant terms and it won't help you in dimensions. This I have shown you because sometimes in the question you might be asked that you need to calculate the force when the medium is any medium, any other medium, it's water or any other medium. Then what you will do, in this formula force, you will write this epsilon to be for medium, right? If you ask about dielectric constant, then you will have to write K and then substitute the value from here. Okay, remember, whatever it is, the general form is this. From this general form, you write the medium, okay, for the medium, and then substitute from this particular ratio the value. Clear? Now the dimension, how you can calculate? I think the dimension is very simple. These all are constant terms. Okay, these all are constant terms. 1 by 4 pi would not give you. So from this, I'm writing directly here. Okay, you can write for dimension of force is ml t minus 2, right? Okay, and it is equals to what? Epsilon m. Okay, for epsilon m, we are doing this 1 by 4 pi, I'm ignoring. Here you will have what? At, okay, A2 T2, because it is for charge, you know, no, charge is what? For charge, it is AT, right? This is what you know, because current is charge per unit time. So from there, you can write the dimension of charge. And here you will have what? For R, the distance, it is L square. So finally, this epsilon m, I'm taking this side. And here what you will have? This will be A square T square, right? Here you will have what? L square. And in the denominator, you will have what? MLT minus 2. So finally, you will get the dimension. Okay, this is the dimension of epsilon m. What you will get? Dimension of epsilon m, it is equals to what? From here, you can just see it is A2, okay? M, it is minus 1, okay? This I'm writing in the third bracket. And here you are having T will go above, T to the power minus 2. So it will be plus 2. You will have T to the power 4. And L will be how much? This is 2 plus 1, 3. So in the numerator, it will be L minus 3. So finally, I'm writing it here. Dimension of epsilon m, permittivity of medium is what? M minus 1, right? L minus 3, A 2 T 4. Directly you can write. Okay, this is how you can calculate. So I think this is clear to you. This is actually very easy. Just you will have to remember the main ratio part. Okay, this ratio part, that your relative permittivity is the ratio of permittivity of the medium to the free space. If you remember this, then you can do a number of sums very easily. Clear? I hope this is simple. And now you will see relative permittivity, or I can say the dielectric constant. Okay, you will have to remember, important thing about that, these two things is that they are having no unit and no dimensions. Relative permittivity and dielectric, you will have to, electrical permittivity will have dimension, but relative permittivity, or you can write dielectric constant. Okay, or dielectric constant has no unit, because it is a ratio, right? And it is what? Dimensionless. And it is dimensionless. less. Okay, symbol you already know. So for vacuum, this is just for your general information. I'm mentioning a few values, okay, of dielectric constant for some medium. For vacuum, the dielectric constant K is equals to 1. For metal, when we are talking about metal, the dielectric constant is infinity. And when we are talking for water, okay, for water, dielectric constant is equals to 80. This is just for your knowledge, okay. It is given in the questions when you are dealing with mathematical sums, but I have just written so that these three basic constants value will remember for this three different medium. So this is all about the permittivity of the medium and relative permittivity and dielectric constant. So I hope all the things are clear. Thank you so much. Have a good day.